All right, so today we're going to kind of go into section 3, section 4, kind of hang that line back and forth. Know that there's so much for us to go through, and I think it makes more sense for you to read through it. So I'm kind of skipping over part of the Learn curriculum where they talk about statistics, like creating their functions for like the mean, median. They talk about the interquartile range. So if these are especially new things to you, make sure you go through them, ask questions on Slack, ask questions to each other, ask questions to me. And we can always talk about it if everyone's like, whoa, this is really confusing. So just know there's a lot of material that I haven't talked about, especially like the intro to statistics. For the most part in the future, like next sections and stuff like that, I'll mostly be sticking with just the one section, but with the first 4 sections, there's so much going on, most of it's set up, and I want to make sure you guys get the full setup going through, okay? So I will reserve part of the end of this class for some like Git stuff, and then we'll actually just talk about doing a pair programming thing. So if you've been having some trouble with Git, I do have a special tool that you can use, so just kind of be aware of that. But we're actually going to talk about some basics of like Python and like really about NumPy and Pandas, which is going to be our main uses as kind of experimenting with as a data scientist. This is kind of like your kind of go-to on your day-to-day with being a data scientist. You're probably going to be using Pandas quite often. It's kind of like the package. Note that there are more when you actually go into more professional like deployment, which is different from you actually looking for things. Deployment usually means that you're working with like a machine learning engineer. You might be using more some different kind of languages, for example, PySpark for Spark and maybe Hadoop and stuff like this. And this is going to be stuff that we talk about way into like module, let's say like 4 or 5. So it's going to be a while from now. But just know that, excuse me, Pandas is going to be your main guy. And it's going to be pretty much all we're going to use in the course. And that's going to give you the most understanding of what's going on. And if you ever go for a question, like an interview, they're going to expect you to know Pandas, at least at some level, especially if you're talking about Python. But okay, excuse me. So again, this is from the repo that's on GitHub right here. So just know it's a direct match. I believe I want to start talking about NumPy. So not to overwhelm you guys, I'm going to minimize this stuff. Why is it not scaled well? Okay, so NumPy basically, this stuff is, what's it called? Like it's a mathematical package built in for Python. So Python's actually very powerful. It's open source and it's used for a lot of fields. And so what's cool is that you'll see is that, well, first of all, Python has its own built-in stuff, but it's not the only thing that's available in Python. So you can, for example, write stuff for Python and reuse that code, just like we saw with a function is like yesterday. So the thing is a package is kind of like a collection of functions and something called classes and objects and stuff. But basically, it's a bunch of code that someone else has written, someone's going to even be yourself, and it's used and imported, and we'll import that into our, basically into our environment so we can use this stuff. So a lot of times, for example, like you'll see like this import, that's what we're doing, basically importing a bunch of code that someone else has written into our thing. If you were to look at like, what is this exactly coming from? They're literally just a bunch of Python scripting files. So that's where all this kind of evolves from. I think I showed this exact code yesterday, showing like how to import. Note that I did the import as NP, PD. These are really common shortcuts. I could have just said import pandas, and then I'd have to type pandas the whole time. So to save on time and just like, shortness and readability, we'll usually import it as a shorter part, okay? So I'll go ahead and run this guy. Oh, one last thing. Before you actually be able to do this, I think, depending how you install Python or Jupyter Notebook, you might have to install a package with Anaconda, okay? So note that we'll come across other packages we have to import, and a lot of times you'll have to install that with Conda or Anaconda, okay? So I'll show you guys that when that comes about. But if you ever see like package not found, it's probably because you haven't imported it in here, okay? Cool. So the first thing is gonna be arrays. So you'll see that arrays are very similar to list, but like as you see right here, this is a list in Python, right? And so a list, as we hopefully you guys know, if in Python now, you can put whatever you want in it. You can put different numbers, you can put different variables, you can put different strings and all that stuff. I see there's this chat message. What does it say? Okay. Okay, cool. Thanks, Rebecca, for letting me know. Basically, a list can take a whole bunch of mess of stuff, which is awesome, right? You're like, cool, I can put whatever I want there. I can put different strings. I can put different numbers. I can put lists within lists even. You can even put functions within lists. You can do some really cool stuff. However, it does actually end up being not as efficient because you don't know. Sorry, I'm just realizing I have some stuff here that doesn't need to be done. The problem is that it's not as efficient because you have to, basically the way Python works is that saying, well, okay, you can put whatever you want in there. So we can't make it structurally efficient because we don't know what kind of thing is in there. So NumPy has something similar called an array, but an array has to actually have the same exact type every single time. So if you have not just like it could be an integer, which is like 1, 2, 3, -1, -2, right? So those would be like our integers, but it also can do like decimal, like what we call floats. And it turns out it has to be exactly the same type. I could not, for example, put in a string in the middle of this. So just to kind of emphasize this point, this is, for example, is perfectly valid Python 1, 2, 3. Okay, and I can see if I print out A, oops. You can see it prints it out. I could also put in like a string here. Okay, and so you can see this perfectly puts it out. And we see it with NumPy, you see numpy.array, this is a function here, and I pass it in a list here. And basically this will convert it into a NumPy array. So you'll see that it looks like this, right? So it's like, okay, that's pretty basic. But if I try doing the same thing with this NumPy, I can do an array like this. And I try doing it with this kind of list. So I'm trying to convert that list into a NumPy array. We'll get an error. Oh no, never mind. We don't get an error. But you'll notice there's something a little funky happened, right? So if you look carefully, you'll see that this is no longer a number. This is now a string. So it actually converted into a special type to basically account for these different strings and stuff like this. So you have to be very careful with this kind of stuff if you're using NumPy arrays. But the benefit of this is that when they're all the same type, so if I change it to this, you'll see now they're numbers. The benefit of this is that NumPy is very efficient with their arrays. There's a whole thing I could talk about with like memory and like computer science. I think I might share a resource at some point about talking about all these parts. But just know in general that it's a much more efficient way of having a bunch of numbers essentially. Okay. One last thing, this is kind of like, this is kind of a subtle thing. So you'll notice that I didn't put a print statement, but it's still printed at the very bottom here. This, for example, I could have done like print like this. You'll notice too when I write this, so watch, I guess I could just copy this. There we go. So I'm gonna go ahead and copy that array. So you see that's when I first printed it out without any print. It looked like this. If I do print right here, you'll see that it actually prints out like this guy going on here. And so note that what's happening here is that Jupyter Notebook's actually pretty smart. It says if the last thing on here, it's going to go ahead and try to essentially print this, but it's actually calling something else. It's not calling a print, it's actually calling something called display. So I'll show you what that looks like. So if I do display now, you actually see that it matches the same thing that was up here. And so just know that the very last line of the cell, it's actually calling display, and that's what it's showing you. But note that, like, for example, if I say like, I'm trying to do like a = 1, that doesn't print anything out, you know, which makes sense if I do like a = 1 here, doesn't print anything out. So that's why it doesn't print anything. So note that's a little different from like what print is doing. You'll notice that sometimes I'll use print versus display. For example, I like using display because it makes it more obvious that this is actually a NumPy array versus like this right here. This looks like a list at first, but if I actually do a print A, that's actually a list, you can see there's a subtle difference here. Versus if I do displays, you can see here, they look very different and it's a lot more obvious to show what's going on here. So you'll see me use display a lot more often for NumPy arrays. Okay. So that was a kind of quick thing, but kind of important. All right, so NumPy arrays. So we can actually do some interesting stuff. So we might remember how we can create NumPy array, or sorry, we can create like things like with range 10. So remember, I think I showed you guys range 10, what that looks like, right? Cool. So you can convert those into lists. You can also convert them to NumPy arrays. So for example, if I go ahead and try to run this, you'll see this converts a range, which is 0 to 10. Right? Stops the 10, it's not the included, just 10 items. And so it actually creates a range here. Note that I used print so that actually it goes ahead and prints out like without the commas and everything. our next part, we can also take something called a tuple. So thumbs up if we're familiar with tuples. Okay, so I just want to kind of review what a tuple is because it is kind of confusing at first. A tuple is essentially like a list. It sounds like it should be just a single, like being tuple. Like it sounds like it's like, oh, there's only two things. But tuples can actually be one thing, 0 things, 2 things, 4 things, whatever. They're essentially like a list. So the difference here is that they're immutable, meaning that you can't change them. If I can't change this tuple after it's actually created. I can make a new tuple, but I can't create a new one or change that one, okay? But I can also make Numpy arrays with those tuples. You can see, yeah, 5, 2, 3, okay? And last thing we have is something called, I didn't show this in Pandas, but in Pandas we actually have something called a series. And so I'm actually making a series. Basically, if you have been looking at Pandas already, you actually will have something called a data frame, and then each column will be a series for that data frame. And so it turns out it looks a lot like a list. So just to kind of show you guys what that looks like to begin with, without having to convert it yet. You can see here, that's our series. And basically, these numbers on the side here are their indexes. Like, oh, this is the first element, this is the second element. We start with the number 0, so the 0th element, the first element, the second element, 1, 2, 3, okay? And that's what a series is. And that could also be like strings and stuff. I can also do the same thing of converting the series. So if you grab like a column from a data frame in Pandas, we can convert that into a Numpy array, okay? And so kind of fun fact here is that a Pandas series is literally the same structure as a Numpy array. And so you'll see very similar operations go between those, what's it called? Operations between Pandas series and Numpy arrays. You'll see that there's a lot of similar things that we can do. And that's because they're literally the same thing. Okay. Any questions on what this Numpy array is or how to create them? Cool. So for right now, pretty much you're like, okay, super list. That's essentially what a Numpy is. Okay, or Numpy array is. So we can see here is that we can actually do some math with it. So anyone know if I take a list like here and I add the number like 4 to it, what this would do? You got a guess?
An error.
An error. Yeah, right? So why did we get an error in this case?
Because you can't just add a 4 to the list or like add each number in the list by 4. It's like different types.
Right, yeah, you're exactly right. They're different types. It basically saying this is my list here and this is a number. I can't just add a number to a list. You might intuitively, like you said, maybe add 4 to each one or maybe add 4 to the list. That might make sense, but Python's like, I don't know what that is. Better just throw an error. You can, for example, like Lauren had mentioned, actually add 4 to the list by doing something subtle where you basically put this list within it. So you can see here, if I print this out now, this will be 1, 2, 3, 4. This is also true. You can put like multiple lists together. So this is like a longer list, right? I can combine them together in this way, and you can see I make a bigger list. So adding numbers to our list basically just makes the list bigger as long as that thing is a list by itself. We can't just simply add numbers, right? Okay, so multiplication, these are kind of fun ones. So remember our list 0 here is just 1, 2, 3, okay? Does anyone know what would happen if we do times 3 on a list?
It would give you that list 3 times.
That's 3 times, good, right? So it's not super intuitive, at least that's not what I would think. But like, you're like, oh yeah, it basically just copies that list 3 different times into one list. And you can kind of think about this. I think like if you think hard enough, you're like, okay, I can kind of see the analogy here. You're like adding the list 0 plus the list 0 plus the list 0, which would add the list 3 times. That's kind of like what times is going on here. So good. What about division? Does anyone got an idea what this will do?
Would it try to divide it into 3 different equal lists, or
that's a good
try to
right?
divide it into 3 different lists?
Yeah, that kind of makes sense, right? Like if you're multiplying it by 3, dividing it by 3, like, you know, if multiplying by 3 makes it 3 copies, maybe dividing it divides it into 3 equal parts, right? It makes sense. Some other options people might think like, oh, maybe it divides each individual number by 3, right? That's a possibility too. So one way to try it out, just try it out. And you see we get an error. And it's the same thing with the plus part. It just turns out that Python doesn't know what to do with this division. It's like, I don't know how to do this thing. They're different types. So note that lists are kind of like different everyone, different parts. So again, adding lists together, we can do this really easily. We can also multiply lists, saying like make a list, basically copy over and over and over again. You can do all that stuff. So you can see this here. So like, okay, cool. Like that's kind of cool. It doesn't do exactly what we want, right? Or at least maybe not what you expect mathematically. And that's where Numpy arrays come in. Numpy arrays work much more like mathematical objects. So like if you imagine like multiplying it by 3, adding 3. So you can see here, I'm going to create a new Numpy array, which is 0, 1, 2, 3. Okay, and you can see here, I can see it's a Numpy array. Okay, and I'm actually gonna, I'll keep it at print since I'm already having it print there. But I can actually add 3 minus 3 times 3 divide by 3. So I'm actually gonna show the very first one. And has anyone got an idea what this might do? We saw it with lists, it doesn't work, right? Anyone got to guess what this might do now that we're working on Numpy arrays?
Now it'll add 3 to like each of the elements within the list.
Right, yeah, and that's exactly what happens. It's much more mathematical. It's like, oh, it's adding 3 plus 1, or 3 plus 0, plus 3 plus 1, and so on. And we get this Numpy array, okay? And then we can see the same thing happens, as you might guess. This minus, times, and divide will all basically do these either minus 3 on each one, or times 3 on each one, or divide by 3 on each one. And you can see here, this becomes into decimal since obviously 3 won't divide into all these numbers equally, okay? Cool. And then you can see here, we can also still combine lists together too. Well, maybe not. Let's see what happens if we add. So remember, when we did a list, right, and we added them together, it just made one big list, right? So knowing what you see from here, what do you think will happen if I add these these Numpy arrays that are 3 elements long, add them together?
Add each number, like the first one in each together to create an array.
Yeah, right? Yeah, that kind of makes sense, right? You add 0 plus 3, 1 plus 4, 2 plus 5. Is that right, Carly, you're saying? Good, right? So let's see. And you can see that's exactly what happens. You can see that different addition. And that hopefully makes a lot of sense. Now, here's a little subtle part in here. What do you think would happen if I did another number right here? Let's say number 6. I'm gonna guess.
Error.
Error? Yeah. Let's try it. Yeah, error. And that's because basically it doesn't know what the next number should be added to. And you'll see here there's something called a shape. And so basically this shape right here, this 3, 4, this is basically saying, hey, this has a shape of length 3, this is a shape of 4. NumPy is like, I don't really know how to deal with this. And so it says, don't know what to do, error. There are some subtle ways you can get around this for certain things, and we'll see that a little bit later. But just know that for the most part, when doing a lot of operations, it's best to make sure they're the same actual shape. Okay. Any questions on this? Sound good? Everyone following?
I had a quick question, actually.
Okay, go ahead.
Are NumPy arrays the only way or the best way to do linear algebra operations with matrices, or are there other packages that we'll run into in the future?
Yeah, so better is always an interesting one, right? Better can mean a lot of things. One could be like efficiency, one is readability. NumPy arrays, I would say, are the best option because it's the most used option. And what's really happening, if you really want to go into like what's going on with NumPy arrays, like why are they better in this way? Essentially, NumPy arrays are using the C++ code that Python is built on top of. So has everyone heard of like the word C++? Maybe programming. You might not know what it is, but you've maybe heard that like in some context at some point. C++ is basically a programming language. Well, those are both different programming languages, but they're related to each other. It's one of, I think it was developed back in the 1970s, but it's meant to be very, very fast. It's relatively readable compared to what was before it, where there's a lot of like, what they call like hex code and like really difficult like things to navigate. So it's a very common language. It's still used today. Basically anything like, for example, your dishwasher is running some kind of programming stuff on there. It's probably written in C. Like that's where that code's coming through. So it's very fast, very efficient, but it's a lot more cumbersome. So Python's actually sitting on top of that, and it uses basically what you type in Python and translates it into C and basically runs that code. NumPy is much closer to that surface of C, when it's actually creating like, again, I'm trying not to get too technical in computer science because it's not really super relevant to us right now, but note that you can come across this I think I'll recommend the book that I think does a great job explaining pandas, NumPy, and all these parts. But basically what's happening is saving it in memory. And so Python normally would have to say, oh, like you give it a list or like a number in the list, like, oh, here's like a 5. And it's like, okay, let me put it like in my shelf over here. And then like you get it like, you add a 6 to it or something like, oh, here's a 6, let me put it on this part of the shelf over here. And someone goes, oh, here's a string called, you know, fish. And like, oh, okay, let me put that string over here. And so what happens is when you try to do, it's like, hey, give me the third element. Python basically says, okay, third element, that was fish. All right, that's on my shelf. Oh, here it is over here. Where NumPy, what it does essentially, when you add in all those elements together, it says, okay, I'm going to put number 1 here, number 5 here, number 2 here, number 3 here, and basically puts it in a nice little order. And it says, hey, go ahead and add all those numbers up together. Find the sum of this. Or go ahead and take those numbers and add 3 to each one. It can basically, instead of looking for each one and grabbing each like this is all metaphor, obviously, right? But like you can essentially grab them all together on the shelf, and like you can imagine grab them all together, and like then they can do the whole process at once and then put them back up at the same time versus looking around going. And that's where the efficiency comes in. Though I would say probably the more efficient one is probably if you did C. Like that's the only way I could probably think like being more efficient. I'm sure someone out there would say, no, there's this obscure package that technically works like a quarter of a nanosecond faster than Python on average. In reality, it's like, it doesn't matter so much. If you care about that much, you should be using another programming language. So cool, but good question. Yeah. Okay, so that's NumPy arrays. And so that's our basic ones. So you'll see here this special multi-dimensional NumPy arrays. So this is where we can actually put arrays in arrays. So our kind of like analogy to this in Python land, right, would be basically a list of lists. So we can actually have like a list of 1, 2, and then another list of, let's say 3, 4, and let's just go ahead and just print that out. And you can see here it's a list of lists, right? And so we can actually, you know, refer to these numbers and stuff like this. So this is actually really nice, is that we can create these things in as NumPy arrays. So one thing you can see too is that you'll see me and other people write these kind of things in this kind of form. And what mathematical object, depending on your math background, does anyone recognize what this might look like to them? It starts with an M, to give you guys a little hint.
It's a matrix.
Yeah, matrix, right? Yeah. So if you're familiar with matrices, you can kind of see that similarity, and that's why we'll usually structure it. And that's usually really what NumPy, when we talk about multiple dimensional arrays, we're really talking about matrices. And then the more general form, does anyone know what the more general form of a matrix is? When you have like multiple dimensions of like you can see I have a list of lists, and I can have like another list.
Are you talking about vectors?
Vector is actually a type of matrix. It's actually a rank 1 matrix, but rank 1 matrix. But there's actually something more general than that. Does anyone by chance know? I don't expect you guys to know, and not that you guys need to. They're actually called tensors. So tensors basically are like a generalized matrix. Basically, you can have like multiple parts. You can have like a list of lists kind of deal, and you can go as far and deep as you want. They used to be a lot less like common and just outside of like pure mathematics or like physics, like general relativity. Now you might hear it from TensorFlow, which is basically using machine learning and stuff like that. So that's where that word TensorFlow comes from. It's from tensors. So yeah, anyway, that's what multidimensional is. So you can see here, I have a multiple dimensional array, a 2D array, a NumPy array. And you can see here, what's nice is that NumPy is so nice. Instead of making this all like junk, like you can see how it's really hard for us to read this all together. NumPy tries to make it into a matrix kind of form. We can also do things where we can pass in, like, remember how we did a range in here? So this is a little complicated, but hopefully you can kind of read this. This range goes from 0 to 3, so it's going to be 0, 1, 2, okay? And then it'll go 3, 4, 5, and then 6, 7, 8, right? So you can see how each part goes through here. So this right here is going to be essentially like a list, right? It's a range, but a list. And this first guy right here is a list of lists, okay? And then so we can see this guy right here, this is encompassing, this is a list of lists, this is a list of lists, this is a list of lists, so this is a list of lists, right? So you can see these can go as far down as you really want to. But basically this is what we mean by a 3-dimensional array, is that there's multiple levels. And you can see here when they print it out, it tries to make this, obviously, you can't really picture a 3D on a 2D object kind of deal. So you'll see here is that basically each one of these elements in here is a matrix. So a 3D array is essentially just a bunch of 2D arrays. Okay, does that make sense to everyone? Thumbs up if we sound good. Cool. I know it looks very complicated, right? But hopefully that like breakdown makes sense. One thing to note is if I try to go like here, so this will be a different size thing, you'll notice that it does not like that. You'll see that my shape also changed. And that's because NumPy has to have each element in there exactly the same size. So if it can't do that, it's just like, okay, cool. I'm just going to just keep this as my element within it versus actually trying to expand it out. And that's because this 3, 4 doesn't work. Similar to this, if I go, this is going to overwrite this part, but this one should be like a 40 array technically, right? You know, like there. If I try adding in here, you'll see that I get this weird thing right here, this list. And basically it's saying, oh, it's kind of like it's hacked to say, all right, this is supposed to be the same shape, but since these aren't the same shape, I'm just going to say this, oh, these are list. And that's how it remembers what that is the same shape and everything. So just be careful with this if you come across and you're trying to program something and you make the wrong shape, it won't make a nice, beautiful little multidimensional object. All right, and then we can actually see this. Oh, this is going to mess up because I changed this. There we go. So you can see here, we actually can print out the shape. So I kind of hinted at this before, is that we can say, well, what's the shape of this? So remember when I showed just a 1D array, basically the shape is this 3, 0, or 3, this is a tuple. So saying, okay, it's a shape of 3, a shape of 4, right? 4 different elements. So this 2D shape, what's going to happen is going to say, okay, it's going to be a shape of 3 elements in each row. Okay, and there's going to be 3 rows. Or I guess 3 rows, right? So you can see here is that there's a 3, 3. Okay, so does anyone got a guess what this 3D array will come out as a shape?
Be 3 by 3 by 3.
Yeah, right. 3, 3, 3. Cool. All right. So you can see basically is that you have this is how you can build up the shape and everything like this. If I had, for example, 1 extra element on the end of each one of these guys. Okay, so I have an extra element on here. Okay. Does anyone got a guess what this will print out now if I run this? So it won't be 3, 3 anymore.
4, 3.
Yeah, 4, 3. It's either got to be 4, 3 or 3, 4, right? So let's see, right? And you can see it's 3, 4, right? And so it's okay. And so that's basically saying it's like the first element, there's 3 rows, and then each one of those rows has 4 elements in it. So that's how it kind of goes deeper and deeper and deeper in here. So you can kind of see something similar is that if I get rid of this row here, that will be now 2 rows, and then each of those rows have this element in here, and this element has, well, there's 3 of these elements within that row, and then each one of these elements actually has 3 elements in there. So this will actually be a 2, 3, 3. Cool. All right, and of course we can go as far as you really want to, and so of course then at that point it's just ridiculously hard to like keep track of. So 3D is all I'm really going to print out, but you can in principle get as far as you want. All right. Cool. Any questions on that? Sound pretty good? Cool. All right. Okay. So I'm gonna. All right, awesome. So we'll talk about some built-in stuff. So sometimes you're like, okay, this is cool, Victor. I don't want to type out all these numbers every single time. That's really annoying. So sometimes you'll use a lot of frequently used operations over and over. For example, if you want a bunch of zeros, well, basically you can do here is this np.zeros, and this will basically create a 3-dimensional NumPy array of all zeros. And I can specify the shape of it. In this case, it's going to be shape of 3, 4, 5. So if I run this now, you can see now is that basically I have 3 different elements, 3 different 2D matrices, right? And then in each of those matrices, right, 4, 5, I have 4 rows, and then 5 elements, 1, 2, 3, 4, 5. And so that's how we can kind of pass in to make these very quick elements. And sometimes you might just want to basically have just a bunch of zeros, essentially. Similar, we can have a bunch of 1s. So basically it's the same exact thing, 3, 4, 5, and a bunch of 1s, okay? So pretty simple, right? It's a nice way to, so we don't have to write all these 1s out. You can imagine that would be quite annoying. You also can say, hey, only write this specific number called np.full. And basically it takes the same shape right here and then actually says, all right, fill it in with this number, 27, for example. And you see here, we actually get all these 27s. Okay. So again, some quick ways you can kind of put things together. You can also do some pretty cool stuff. For example, you can use range. So remember, range goes 0, 1, 2, 3, 4, 5, right? So you can actually say, okay, make an array of 5, but using these numbers 1, 2, 3, 4, 5. If you do this now, you can actually see, well, I guess 0, 1, 2, 3, 4. Forgot the fifth one's not included. But you can see here, it makes that nice little thing. Like, oh, that's pretty cool. So this is kind of a convenient way. This is probably a little more, to be honest, I kind of find this a little redundant. It's a nice kind of cool trick, but you could basically replace this with like just np.array. But anyway, so you might say, hey, let me go ahead and try to do this. And this doesn't work. Unfortunately, it won't work with multiple dimensions, which is a shame because that would have been awesome, right? But at least you can take this guy and at least figure out those parts, right? Any questions?
So the NP full 5 range 5, what is the first number again?
That's the shape. So that's the shape of that thing. So that would be equivalent to what we saw, like 5 comma.
Oh, like 5 different. So it has to be 5 and 5. It couldn't be like 6 and.
Yeah. So let's see what happens if I do 6, right? That's a good point. So let's try. You see a value error. Basically, it doesn't match. It's trying to put that thing into a shape of 6, but there's not 6 elements.
Okay.
And we should get the same thing if we do a small.
Okay.
Cool. All right, good question. No problem. All right. So any other questions?
Yeah, I had one more.
Yeah, go ahead.
Is there ever going to be a need for us to quickly or efficiently create an identity matrix? If so, is there a method for that?
Yes, there is. So if you're not familiar with identity matrices, if your math background is not as thing, you can actually do np.I. And you can see here, it's kind of weird because we have I, because it's like, oh, it turns out, if you're wondering like, why is it EYE? It's because this already exists, I think. And that's, no, is that because, I'm trying to remember why it is I that way. Actually, I wonder now. Anyway, I thought it was because the np.I would be confused with the imaginary number, but that's what I have. I think you might even be able to do identity. Oh, you know what? This is kind of my age. I use NumPy back in Python too. I wonder if I is not really used anymore. I bet it's used now, identity. But that should do the same thing. Cool. But yeah, super convenient. And all we have to do, since identity matrix, if you guys don't know, basically it's a square matrix. So like a 5 by 5, and then just has ones on the diagonal. So all I have to give is just basically that single dimension, and I can give it whatever I want. Okay. Again, a lot more convenient than you actually typing that all out or some other fancy way. Cool. All right, so I'll lead to the last thing on here for NumPy is slicing and dicing, unless there's any other questions. Cool. All right, so slicing and dicing. So this is where, first of all, are we familiar? Give me like a thumbs up and like gauge of like how you feel with slicing for lists. So thumbs up, you're like, I know what slicing is for list. Thumbs sideways, like, I think I know what that is. Thumbs down, I don't know what you're talking about. And it's okay for this way. All right, cool. Thank you for being honest, Brian. Like, that's perfectly fine. So slicing and stuff like this. So if I have a list, let's say, I'm going to do a quick thing. So I'm going to do a range of 10. Okay. So I now have a list with 10 elements in it. Okay. So if I want to get the very first element in here, I can do a bracket and say, give me the first element. And remember, in computer science, we count by starting at 0. Unless you're MATLAB. MATLAB counts by 1 for some reason, who knows. But in most programming languages, you start with 0, counting through. And you can basically grab the very first element. So actually, I'm going to change this up a little bit. Let's do 10 through 15. Okay, so the first element should be 10, and you can see I got the very first element going on here. If I wanted to grab, actually, this here. If I wanted to grab the second element, what would I put in here? See number 1. Good, awesome. You guys are great. All right. And what if I want the last element? There's a couple options here.
You can do -1.
Nice. -1. Yeah, -1. Good, good. So you can basically count backwards. You can count from the end, which is like, oh, that's really nice, right? So there's some other things we can do too. What if I wanted to grab the first two elements?
0 to 1, 0 colon 1.
0, what was that?
Colon 1.
Colon 1? Remember, it'll only grab that element. So remember, it doesn't have the second, right? Good. I see Jeffrey put in 2, right? So we could do this way. All right. There's actually another way too. Does anyone know what the secondary way we could do to grab the first two elements?
Can you just do colon 2?
Yeah, good. And it basically means start at the beginning up to number 2. Okay. And then if I wanted to grab the last two elements, you can do the same thing. Either you can do like, you can count out, what's that? 0, 1, 2, 3. I could do like 3 colon to the end. Or since we have our fancy new negative numbers, we can do -2 to the end. And that's what I basically say. All right, go from the -2 end and then go forward. Does anyone know how to count a list backwards by chance?
Yeah, if you want every element in the list just in reverse order, you do colon, colon, -1.
Good. So we can do -1 like this. And basically what's happening here, this right here is saying grab the whole list. So if I took this part off, that's grabbing the whole list. And then that extra colon is saying, how should I count? And basically that -1 is saying count backwards. So that's what's going on here. So this would be equivalent to if I wanted to have, if I grab the first element, I'll start with 0 explicitly and go 0, 1, 2. Let's stop at the third one right there. This will say grab those first 3 elements, right? And then reverse them. So you can see here. Oh wait, I'm sorry. I always get this one wrong. It starts counting backwards. And so it's like trying to go backwards and stuff. So you can get some weird things in here. But in theory, this would be the right way. You could also do things like count by 2s. So note that, for example, if I wanted to count like 0 to, let's say 4, okay? And I can count by 2s. So I start at 10, skip over 11, go by 12. And so you can count by that way. If I wanted that whole list counting by 2s, you can always do this guy. This is like a nice little shortcut. This is called Syntactic Sugar that's built into Python. So I'm showing you all this because you can do some kind of funny stuff. For example, you can also count backwards by 2s. So you can see here, going backwards. Okay. I'm showing you this because NumPy tries to stay true to what Python looks like. So if I actually create, for example, this is just a random NumPy, random ints using 0 to 10s, size of 5, 8. So basically saying, all right, 0 is my low end, 10 is my high end, pick random numbers and make an array 5 by 8. You can see here, I get 5, or I guess say 8 by 5, well, whatever. 5 rows and 8 columns, right? So you can see a bunch of random numbers. So I'm just creating this part here. If I want to get the very first element in that NumPy array, okay, I actually will get a row. Because remember, the first element in that NumPy array is this guy right here. So I actually get that first full row. If I want the last row, I can get -1. So that would give me that 5, 2, 9, 3, 0, 7, 4, 9. If I want multiple rows, I can do the same thing where I'm getting, okay, 1 to 3, basically from here up to here, right? So if I run this now, you can see I get that very last row right here, and I get these last rows right here, 1 to 3. So basically starting from here down to here and stopping at the third one. Okay, so this is kind of a way to kind of grab multiple parts within NumPy. All right. You can also do some kind of funky stuff right here. For example, you can see I have just an array here, row to start, row to end, column to start, column to end. So you can get like within little matrices within there. So I say, okay, get the row end starting at, or row start is 2. So I start at the second row, right? Or I said, I guess like the third row. But I start at this row here, and then I'll end at the last part, which I think I must have changed this up, right? Let's see what happens here. Okay, I got it wrong. Okay. I don't know why I called it row start. I think that's not the right way to say that because it really should be the end or column. So I've had these flipped over. But this will grab these parts going on through here. So I got 717, 403, 307. So I think actually, in this case, I wrote this wrong, probably because I had something different at some point. So if I wrote this out to like 88 and then run this, there we go. So what happened here is that I got to 7, but there isn't like a 7th row So it cut it off essentially on there. So now I'm actually getting the full amount here. It stops at 056, which is the 7th row. You can kind of see, what's that, 985, 453. Yeah, so I can't really highlight just those ones, but you can kind of see that little rectangular part in there. Okay, so this is what you can splice. To be quite honest, don't expect to like absorb this and like be able to reproduce this now that you've seen it once. It takes some time, takes some practice. You can see me even kind of like, wait a second, is that right? So just know that this is kind of something that just takes practice and sometimes just like playing around with it to make sure that you're grabbing the right things. But really useful, especially when we start doing any machine learning like deep learning stuff. It'll be really important to do this, but also since NumPy is literally a pandas series, and basically pandas is built on top of, what's it called? Our data frame, pandas data frames are built on series. Basically, this is another, you'll see this kind of terminology used because it's basically translating the same thing back and forth. Okay, cool. Any questions about all this stuff?
I just have a question, like how you wrote the code in that last box. So you have like print on one line and then array on the next line, and like it kind of just goes down. Is that typical, I guess?
Yeah, it depends. I definitely wrote this out as like, yeah, I'll show you guys what this looks like. If you, like, you can do that this way. Typically you won't see people write this way because usually it takes more time to actually write it this way. So this is probably how you would likely see it, which is a little bit harder to read. At least for this case, it's like hard to see through. Python, as you guys might notice, is that you can't just simply just go to the next line. So for example, I can't do like, I'm trying to think of an example, like 1 equals, let's see, or sorry, A equals G, and then I'll write, so like this, it'll give me an error here. It says, hey, you can't do that. However, Python's like smart enough, was like if you put a parentheses around each part, it will actually consider those parts. In this case, this actually won't work because this is for a string, but the idea here is that if you have parentheses at the end, right here, it will just say, oh, let me read this as one big thing. So this is kind of a nice little hack going through. You typically won't necessarily write this way. I think sometimes it's nice though, when you're trying to make it readable, and you can do it this way. If you do all your stuff like this might be a little too cumbersome for people to like actually read it through. But usually you'll see it written like this, if that makes sense. Okay, cool. All right. Yeah, so cool. Good question though, because I know that's kind of a little different from what you normally would see. Anything else that you guys, questions you guys might have? Okay, cool. So that's kind of NumPy. So there's a lot more in the curriculum itself that talks about NumPy and then into Pandas itself too. I'm going to actually kind of hold that off a little bit for Pandas. You should practice it because we're going to actually do, what's it called, some pair programming. I'm going to show you guys what that looks like. So I'm actually going to stop the recording here. If you guys are all good, I don't think it makes sense for me to record the rest of this.